Hi, everyone. Yeah, I'm here to take you on OSI model and TCP IP model. But before then, let's say a brief history of this, the reason for this. In the 70s, telecommunication equipment from different vendors could not, communicate. You know, there was a barrier. IBM computers could not communicate with other computers from other vendors, computers from other vendors. Okay, that's a short, brief history of it. In order to break this barrier, a, you know, organizations like International Organization for Standardization came in to create, open system interconnect in order to break this barrier, to ensure interoperability. Okay, and 7 layers were, developed to ensure, that computers from different manufacturers can fit in. Okay, so they developed 7 layers of OSI model, ranging from up to down. Application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer, which is layer one. So now you as a student, you need to familiarize yourself with this because Cisco asks these questions, okay, for you to arrange the OSI reference model in order, okay? So for you to remember it, this is where the slogan they use, all people seems to need data processing. All people seems to need data processing. All is A, people, all for application, people for presentation seems, for session layer to need data processing. Okay, with this you can remember it. Okay, so now they did this and created these 7 layers. Okay, so now let's analyze each from up. Application layer is a kind of an interface between applications running inside a computer system and network itself. And a good example of these applications, is the Internet Explorers. Okay, when a user of computer open Internet Explorer and start keying in web address, you are making use of application layer. Okay, trying to make web requests, communicate with the web server. Okay, you making this request is the web client, while the destination computer is the web server. Okay, when you make this request, keying these addresses, you are at application layer protocol. And inside this application layer protocol, there are some TCP protocols, okay, running there, such as Telnet, okay, which uses TCP port number of 23. Okay, another one is HTTP, which is Hypertext Transfer Protocol, is a protocol of the web, okay, for making web requests. And it uses TCP port number 80, okay, port number 80. So another is FTP, which is File Transfer Protocol that runs inside this application layer, which uses TCP port number of 20. Okay, another one is DNS, Domain Name Service, uses UDP port number of 53. Okay, those protocols are running inside the application layer protocol. When, let's come to presentation layer. Presentation layer ensures how data is being presented, how data will be presented, data format, as it's going to be presented. Okay, data formats like, doc files, PDF files, MP3, MPage, making sure that this data is translated into human readable form. Okay, that is the work of presentation layer. Okay, and presentation layer also ensure data encryption. It encrypts the data and also responsible for decrypting it. Okay, so let's come to session layer. Session establishes session between source and destination computers. It establishes a kind of virtual circuit and making sure that that session remains intact until the two computers, finishes their communication. Okay? If it is file transfer, it maintains that session until the two computers finishes this data transfer, and it is also responsible for terminating this session. Okay, and when data is at this thread stage, data is still data. Okay, now transport layer protocol. Transport layer protocol ensures data delivery, flow control, window sizing. Okay, the way it manages the way data, flows, making sure that data must be delivered. There are two important protocols running inside this transport layer, TCP and UDP. Sorry, UDP. TCP is a transmission control protocol, which ensures reliable data delivery and is also creates what is called three-way handshake between source and destination computers in form of, this is source computer, this is destination computer, is send an, sync message, okay? Sorry, N-Y-N, okay? Sync, and destination computer reply with sync arc, okay? And source still send again and said arc, acknowledged. Something three-way handshake. Hello, and he said, yeah, I'm here. Okay, it says, okay, we are ready. A kind of something like that. When this three-way handshake is established, they are ready to communicate, okay? And TCP is a connection-oriented protocol also, it shows reliable data delivery. When source computers send like 5, packets to destination computer, and maybe one get lost on each way to destination computer, TCP must make sure it resends that lost packet to destination computer, making sure that destination computer received it, that all packets are being received. Why this UDP is a connectionless protocol, which does not care whether data is delivered or not. It just sends data, but is still important to some applications like voice over IP, okay, and the video conferencing or video conferencing, okay, which does not need to, need to checkmate, because TCP also, ensures error detection and error correction. Okay, so UDP is faster enough and can hold, communication between two telephones or between two computers that establishes video conferencing. Okay, so at layer three is where, routing. It ensures movement of data from source to destination computers. From source computer to destination computer. It routes file by looking at the best path to deliver that file. By adding IP header, internet protocol IP addresses run at network layer. Routers runs in network layer protocol. Okay, so that is network layer. Data link layer ensures, framing. Okay, addresses like MAC address, media access control, operate in this layer. Okay, Ethernet, a protocol of, network, local area network, such as Ethernet, like Ethernet switches, operate at data link layer. Okay, frame, when data is placed into data link layer 2 from packet, it converts to frame. Okay, Wi-Fi devices like 802.11.11, IEE, IEEE 802.11, which ensures Wi-Fi, is a Wi-Fi standard developed by Institute of Electronics for Electrical Engineers, runs in data link layer. Okay, that's it. And at layer 1, this is where ones and zeros. Okay, it converts, frame into ones and zero for transmission within transmission through cables, electrical connectors, RJ45 connectors, which terminate, at both ends of network cable. Okay, fiber optic cables, those runs in layer 1. Okay, 0 and 1s. Okay, so data encapsulation, when data is here, let's say this is a source computer, okay, this client computer wants to communicate with web server. Okay, this is a web server here. Okay, so data stage, when data comes to, at these 3 upper layers, it's still at data stage. This is the data. When data comes here, layer 4 header is added and data is broken into segment 1, segment 2. So the segmentations happens at layer 4. Okay, and data comes to layer 3, which is the network layer. Okay, it's placed from segment to packet, and where IP header is added, IP header for routing, the movement of data. So when this data comes to layer 2, remember it's coming from up. This is IP header. Okay, frame, data is placed into frame. Layer 2 header is added, and remember it's frame. Okay, comes to layer 1. This is still that data. This is segmentation, segment. This is IP header. This is frame. And layer 1 header is added bits, zeros and ones. Okay, and move to destination device that, each corresponding, layer read this data. This is the data. Okay, when they read this data, remember this is removed here and passed to network layer, because here is at TCP IP network interface, the combination of layer 1, layer 2, and layer 1. So now bits and framing are removed here. Then data is still here with, with packet, okay, with the IP header, that is the S segmentation and the IP header. And when it comes here, IP header is removed. It will read the data. It's just like a packet, okay? An envelope, remove it, open it, a package, and remove each header, pass it to the upper layer, okay? Now, this is data, and this segmentation is removed, and the data is here, and that is it, and comes back just the same way to, this computer made a web request, and the web request must be, served. That is why it's called server. And when it's serving that server, that content, it is followed that way back to this destination source computer. It's called data encapsulation and data decapsulation. Okay, so that is how it works. These are the rules and regulations, protocol and standard that was developed by international organization for standardization, so that equipment from different manufacturers can communicate, can interpret. Okay, thank you, and see you in the next video.